In this episode, we will look at the business configuration, generate the table, and various helper views to maintain the configuration via a Fiori UI. First, we will create the actual table, which we will create according to the data model. You can find the data model on the Recycling Heroes overview page in the video description. Let's create the table using the context menu of the Project Explorer. We will define the configuration ID as a key, assign a process to each configuration, and have only one value and one high value for each. This allows us to maintain various settings in the system that we will later use in our processes. Once we have defined all the fields in the table, we create the corresponding data elements and domains in the system. We can easily create the elements using the forward navigation. In the case of the configuration, we want to define some values directly that we will also use later in the process. Here we define values for whether APIs are active in the system, various default values, and modifiers for default values. Once we have finished defining them, we can activate the elements. In the next step, we define the process and also create the data elements and domains here, since we want to create fixed values in the domain. There we define the various modules of our solution. For the value, we need the domain because we want to support uppercase and lowercase letters. In the case of the value, we use the same data element for both fields and adjust the text later via the UI. Before activation, we adjust the delivery class and the data maintenance of the table. For the business configuration generator, the table must be set to customizing and maintenance must be enabled. With this, we can activate the table and proceed to the next step. For generating the maintenance stack, we use the generator for the business configuration maintenance object. This makes the complete wrap stack available to use it in a singleton pattern. First, we select the same package as the table where all objects will later be generated. In the next step, we need to configure all the settings in the generator. For this, we deactivate the transport setting and adjust the names for the various objects. Further information on the business configuration, its creation and customization can be found in the video description. Once we have finished configuring the settings, we receive an overview of the object that will be generated in the system. Clicking Next creates all the objects. This may take a while. As soon as the generator process is complete, we receive a pop-up and can navigate to the maintenance object. Then we must activate the service so that the entity appears in the app and can be maintained. Let's test the maintenance and go to the Launchpad to start the custom business configuration application. In the development environment, we see all created maintenance objects and can search for our new maintenance object. If we select the entry and load it, we will find that we do not have permissions to enter edit mode. Therefore, we must create the permissions as a first step. To do this, we create a new IAM app in the Fiori package to assign the permissions. We need to specify a business configuration as the type. For this, we go to the Service tab and enter a new OData service in the development object. To assign the appropriate permissions, we switch to the Authorization tab and add the object tabunam there, so that we can grant permissions to tables and the core data service. For the table, we first need permissions for the change documents and then a second permission for modifying and reading the table and the core data service. With this, we should have all the necessary permissions to perform the maintenance. Once we are finished, don't forget to use Publish Locally to publish the permissions. As a final step, we go to the business catalog and add the IAM app so that the admin will also receive the permissions later. Publish the permissions here as well so that we can test them in the Launchpad in the next step. Now let's switch back to the app and refresh the browser to reload the application and the permissions. The Edit button is now active and we can maintain our first entry. When saving, we currently receive an error message stating that we need to specify a transport. We actually generated the entry without a transport. There seems to be a small bug here at the moment. Therefore, in the next step, we adjust the maintenance. After generating the wrap object, we can freely customize and extend it. Therefore, we now delete all connections to the transport record from the object. Let's start with the behavior definition and remove the various components of the configuration in the form of side effects, validations, and actions. After activation, we can go into the implementation to remove the methods there. We can remove any piece of code where we now receive an error message, as these are the deleted objects. If we no longer receive any error message, we can activate the class. Finally, we remove the buttons from the UI. To do this, we go to the core data service, since at the singleton level the UI annotations are located directly in the view. There we remove all annotations on the transport field as we no longer need them. Once we are finished with that, we can go back to the Fiori application and reload it. All transport-specific elements should be now removed. Therefore, we create a first data record and save it, which now works without any problems. Let's now define the new value helps that we want to use as dropdowns during maintenance. As a first step, we define the help for the configuration and use a view entity for this. After that, we can clean up the view, since we will use our IDE action to generate the join. We want to create a value help based on a data element and specify the field name, which will be generated as an alias in the view. After generation, we want to activate the dropdown for the field. We define the second value help based on the process as well, using the same steps as for the configuration. With the IDE action, we can also use the search help to select the appropriate data element. Once we have created and formatted the two views, we can adjust the business configuration. For this, we add one or two additional associations to the configuration view to make the text available in the view. For this, we also connect the ID and the process in the view. Then we define the value help for the field using annotations. We use the two view descriptions to display the text in the UI instead of the key. Through the arrangement, we ultimately only see the text. Once we are finished with that, we can adjust the heading of the second value field to visually differentiate the fields. After that, we need to add the two core data service to the service definition so we can use them later. Before we can test the UI, let's take another look at the service binding. There's still an error here because we modified the field structure of the interface level. Here we should recreate the draft table. This completes the table maintenance and we can now manage the values in the app. However, there seems to be a minor issue with the text display, at least while the values are still new. It generally works after saving the values. This allows us to manage the entries later without having to deploy a custom UI, which saves us complexity. That brings us to the end of this episode, and we will be taking care of the API next time. Thanks for watching and see you next time.